Hey guys, welcome back to my channel. I think this is the very first time I've ever made it. I'm about to make a video on anything other than scrap mechanic. So to get straight to it, this game is called Shenzhen. It lets you make electronic circuits, program them, and lets you make entire products. So I love games that teach you stuff. You know, you have a lot of games like that nowadays, like Kerbal Space Program drew me in for hundreds of hours. Scrap mechanic. I think like if kids at the age of 10, you know, nowadays are playing these games, they're just learning so much more than I learned in school way back when. And I think I just saw this. I had to buy it, and I had to have it. And now I went through the first two missions. I had never looked at circuits. I have no idea how to program circuits. It gives you here a 40-page data sheet. It's written like a manual for microprocessors, and it took me a while to kind of get smart with this because it's not very user friendly, but you can jump in this and figure this stuff out because everything starts out very easy. So let's get straight to it. I'm an engineer apparently from the UK, based on all these emails, you know, and I work for a Chinese company now because apparently they don't make stuff in the UK anymore, and I came to China as a hungry engineer. So it's telling me to read the manual, and then here's my first product. I've already started with this, but so let's just jump right into the first mission, guys. So this product is an imitation, a fake security camera. It has two blinking lights. The first light blinks in a regular pattern. The second light is an intermittent light, so it should be blinking in a more random intermittent pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer left before finishing the assignment. So yeah, you now go straight into the CAD. This is my design, so I'm gonna delete this. Hopefully I can do this again. And this is the design when you came into the mission. Up here is what you had already. Alright, so I had to look all these things up, partially in the manual, partially in the I had to Google it. So if you guys want to figure this out on your own, it's a lot of fun. Don't watch this. This is going to be more like tutorials. I'm going to tell you guys what everything means as it's applicable to each mission. I don't want to tell more in the beginning before you guys get to use it. Alright, so first we have these chips up here, the MC4000, right? It's got an accumulator. An accumulator is basically like a temporary storage unit. And it has these pins, P0 and P1, input output. The X buses we're not going to use, so I won't explain those. Alright. So now all you do is, this was already wired up from the active to the P0 output. This is an output to the light. Active is a light, right? So it has already the coding. And now if we click on the verification tab, here I'm just gonna simulate. You can see the top graph is the red light as it blinks on and off, right? So like lower here it's 0, a signal is 0. And let's go through it step by step. Alright, so step, it's move 0 to P0. So basically it's moving the value. Moving means either a register or an integer. So an integer of 0, which is a value 0, which is a percentage. The signal strength is 0% to P0, to the output port of P0. So you step. Now it says SLP, means sleep 6. And you see these shaded areas? These are each a step. So you have 6 steps here. 1, 2, 3, 4, 5, 6. Alright? So it sleeps 6 steps. You see the little browser, the little arrow. So each time I press step, it sleeps 1 computing step. And you can think of these in like a unit of hertz, you know? So it's just a time unit. So 6 time units. Alright. Now the next instruction is move 100 P0. So basically move 100% signal strength to the output port of P0, okay? To active, you know? Alright, so now step, sleep 6. And now it's basically the CPU is not doing anything while a signal gets transmitted for these 6 steps at 100%. And you can see that on this graph, 100%, right? Step, step, step. So this is our fake camera, and the red light is on for those 6 time units. So it looks like this camera is active, but it's not actually recording. It's just like a deterrent. You know, this is the product we're making. We're gonna sell this product. Our company. I forgot what our company name is. I work here. I should know this stuff, right? All right. Step, and then next instruction: move 0 P0. Puts us back to 0. Sleep 6, and so on. And you simulate this, and you can see down here the red light blinking off and on and off and on according to the signal strength of either 0 or 100%. All right. Now, so what we actually have to do here is make a network light, the blue light, that has this pattern, kind of something more random looking, intermittent, so it looks like it's uploading data, right, to the cloud or whatnot. Alright, so this diagram below, you know, we've already imported the chip here, so now we're gonna reset this. Alright guys, so let's do this, right? So the first line I can tap on here, and then I can type stuff. I gotta type commands. I can use the same commands we have up here. So let's see what's going on. So we want to imitate this graph that we have down here. That's what we want to output on our P0 output pin, right? So alright, you can see we can count 1, 2, 3, 4. So we want 4 time units of a signal strength of 0. So we're gonna press move 0, signal strength of 0 at the port P0. Alright, enter. Now we're gonna tell our, so it's not going to output anything. We're going to tell our CPU to sleep for 4 time units. Alright, so it sleeps 4 time units, and now we want a signal strength of 100%. So move 100 P0. So this is where we are. We are right here. This is where we're starting. We're now telling it to output a signal strength of 100%, right? Alright, now you can see this is 2 time units. 1, 2. So sleep 2, right? Then now we're here, so now we need we don't want to be outputting any power again. We want the light to be off. Move 0 P0, sleep 1. So you see it's only 1 time unit. Now another time unit of power, so once again we turn on the power to the light, and the light will blink again. Move 100 P0, sleep 1. Alright, so now we're here, and now, since we're at the last line, our chip is going to start at the first line all over again. So it's right here. It's going to execute everything the same. It's going to repeat every time. So we don't have to do anything anymore. Let's go through this right now, step by step. So you can see it moving here in filled in yellow, right? All right. Now the blue light comes on. It's still on, now it's off. You know, see how it interacts with the graph. And then we can just simulate in real time. See the blue light blinking, what seems to be intermittently. It's of course doing the same thing over and over again, but yeah, and you can see up here how it's just reading the instruction. And I guess I'll show you guys, let's see if it reflects in the accumulator. So advance. Yeah, so the state is just the computing state, and it just switches between executing and sleep. So it's either executing instructions or sleeping, which you really have to go through step by step to see it. If you keep your eye right here, and then the power, each time the chip goes through an instruction, it adds 1 power unit, you know. So you can see here our production cost. So in order to finish the mission, you just simulate it and you do 4 test runs. Current test run you see right here, 1 out of 4. Every time it goes through this graph once, it completes the test run. It shows you the power usage, so 60. So it looks like we have 60 time units per simulation. And since we have here 1, 2, 3, 4, 5, 6, 7, 8. Alright, I'm gonna hold off on that statement. Well, let's see. And yep, so it did 4 test runs, so it's telling us verification complete. But we're gonna continue editing here. I just wanted to see one more thing. Oh, okay, I see. So for each execution of the instruction, it uses 1 power unit, but it doesn't count for sleeping. And since you can sleep through these time units, you know, so you can calculate exactly on your own how much power you're using. So that's pretty cool. Alright, so our fake security camera is done. Now we're gonna make the next product, which is as far as I've gotten. Maybe if you guys like, comment. If you guys wanna follow me in the videos and stuff I haven't done yet, so you can see what like the thought process is. But it took me just a while to figure out these really simple instructions, you know, because I've never seen anything like that before. From what I understand, this is like, you could now literally order these chips on Amazon or something and program them. It's a real simulator. So this is like really teaching you like real, I guess, logic gates and circuits and that simple microprocessor specific program. I don't even know what the actual programming languages names are. So I'm just gonna shut up. I'm just gonna focus on the game. I'll find out more. I do want to buy these parts in real, like buy little LED lights and buy little processors and program them and translate what I'm building in this game, because ultimately we're gonna make more complex stuff and put it into something real. So I will do more research on that. I'll have more on that later, but for now we're just gonna go through the next mission. Alright, we have here a replacement factory module. Our factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken. This is an appropriate project to teach you about inputs. And then smashed! Hang on a sec, what happened here? Is everyone okay? No need to worry. Alright, so, you know, he said looks good, thank you, because I've once again finished it, but we're gonna go through this together. Open in concept CAD. Yeah, so new design not yet verified. That's the one we're gonna open. And so I've already gotten the MC6000 bridge. We don't need that yet. Technically, if you're at this mission, you wouldn't have that yet. You get it after this mission, and then you would just drag this chip here. But I've already done that. So you can drag these things anywhere. All right. So control in. So we're getting a signal from another. You know, like this, all this is an amplifier. So we're taking a signal that's coming in from this control input into P0. We're going to amplify it. So it says down here, it's telling you to multiply it by 2, the signal strength. And then we're going to output it. Control out. So that's it. As far as the wiring goes, now we just need to program the actual instructions. Alright, and this took me a little while. So first, you know, you got to put the whatever the signal strength, you're putting it in the accumulator. You're putting in your memory storage. So you're gonna say move P0, and I could be wrong on this. I think this is what I did, to accumulator. So move, you know, port, and like from what it's coming comes first, and then to what it's going, the accumulator comes next. That's how the language goes. All right. So now what do you want to do? I think you want to multiply MUL this by 2. Then you move what's in the accumulator to P1, and then you sleep 1. I think that was it. So the logic is basically, we're gonna have and you're gonna see this when I go through it step by step. We're gonna have whatever signal strength comes in here. We're gonna register that and put it in our memory. It's gonna go in here. Then we're gonna use. So technically, multiply, the command is take last operand, which is going to be what we stored in here, and multiply by 2. So it's going to take that value in here, multiply by 2, and then we're going to take the new value that's now in the accumulator and move it to the port P1 and output it to control out. You know, so it's just an amplifier, very easy. And you actually have little electronic components that make up actual, you know, things. In your devices right now. You know, you have so many components, and this could be like one of 100 in anything. You know, maybe this is what happens in an amplifier in your car stereo or whatnot. Anyway, let's click on verification. So this is what's gonna come in from control in. This is gonna be the signal, and what we're supposed to be putting out is this. So you can see like all the peaks are twice as high. Yeah. Alright, let's do it. Let's simulate, see if we're running good. Yep, so the first simulate it again. I just want to record the power storage and pause. So the first test run is complete. It was in sync. you know, if it wasn't, like, we could, I'll give you guys an example, and it has a power usage, like, I'm gonna do it purposely wrong, right? And don't worry, I'll explain this more in detail. So we're gonna multiply by 4, and you can see here in red it shows where it's out of sync. So everything on these graphs have to be in sync. Okay, so I'm gonna make this correct again, multiply by 2, because that's what we want. And now we're gonna go through this step by step. Alright, so you can see here it says 25 all of a sudden. It didn't say that before. So this is showing you that from the control input we have a signal strength of 25%. So when this is highlighted, this means that the next time we click step, it'll execute this highlighted command, which is move P0, so signal strength 25%. We're storing that value in the accumulator, which is our memory. Step. So now you can see there's 25 in the accumulator here, right? So now we have executed that first command, and we have the value of 25 in the accumulator. So what's highlighted as the next time I press step, it'll execute this highlighted command, which is multiply by 2. Multiply the last operand by 2, and the last operand is in the accumulator of 25. And I assure you guys, I've never done this before. I literally just looked 10 minutes at the manual, and I'd kind of like programmed a bunch of random stuff and saw what happened on the graphs, and then I figured it out. And that was the most fun part about this. And this is gonna get a lot more complex. So anyway, let's keep going. Yeah, so we're gonna press step again. Now you can see after we've multiplied, the accumulator says 50. So now the next command when we press step will be move accumulator to P1. So what that means is move the value in the accumulator to the output port of P1, which will then send it to the control output. So that value of 50, right? So step, and now it's just gonna sleep one. Step. So here this is 25, this is 50%, and you go through this again. So now it's actually giving a signal strength of 50. You can see it up here, and you can see it on the graph, and you go through it. It multiplies it by 2 to get to 100. It then sends out the signal here at 100 at twice the strength. The signal has been amplified. Yeah, I mean, this is it. And as it goes through it, like the power, and let's talk about the power a little more. I think it's easier to understand here. So we use 240 units of power per run. So we have 3 execution commands. Let's go through it. Power says 1, power says 2, power says 3. Sleep 1. So sleep 1 apparently is also registers 1 power. So we have 4 power per step, which means we probably have 60 time units here per simulation. So if you had 8 lines of code basically instead of 4, then your power usage would be double. So in the end, you know, it's probably gonna just in the more complex products that are to come that we're gonna produce, you probably have to be efficient, you know, which means basically being efficient in your code, just making it as short as possible to keep your power consumption down. So yeah, guys, that's all I have for you guys today. I just really wanted to pump this out because this game I think must have just come out a few hours ago. There's only 46 reviews on Steam. Every single one of them was positive, and I read it and I was like, man, these guys sound like they've actually programmed in real life before, you know? Like, none of them said here, like, I had no idea what I was doing in the game before. So I was kind of intimidated, but I was like, screw it. I need to get this game. I need to try this out, especially because I'm actually going to go to college soon for electrical engineering. But I don't actually have any idea. I had no idea what an accumulator was before. I had no idea what, you know, MOV, P0, ACC meant before. But the nice thing is you start with super simple projects like the first one, the fake camera, which is just make this light blink at these time intervals. And we're going to get more and more complex here, and I would like to do a tutorial on each of these products. I think there's supposed to be 40 products. This is still an early access game, so they might also make better tutorials, more products, and maybe more like story, I guess. But yeah, that's as far. Well, actually, let's look at the latest one I've gotten. I haven't finished this yet. Oh, this is just saying, please enjoy a game. He's saying that his daughter, the boss's daughter, has made a game. She wants us to play it. So there's apparently more to this game than this program. Man, Chinese solitaire, that's crazy. That's probably harder than than programming these chips. Alright, maybe, so I'm supposed to make a pulse generator. You know what? I haven't gotten to this, but let's just do it together. Let's make this interesting. We're gonna do this together. You guys can see how stupid I really am and how long this will take me. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements. However, instead of buying one at the market price, I thought we could simply create our own, because we're engineers. For this project, you will need to make use of conditional executioning. Please continue your study of the language reference. Okay. Open design. Alright, so what I've done one thing, which is drag the M6000 here, and it's basically the same except more X buses, which I haven't ever used yet. We have the same amount of P buses, which is just our basic input output, and we have now a data module. So DAT is, just from what I read in the manual that came with this game, a second data storage, a second memory, so we can, you know, store two values, and we can manipulate those two values. So we'll have more options of doing stuff. So alright, let's go to verification. So this is the button, right? So let's start with wiring up the button to P0. Okay, bam, it's wired up. So now the signal can come to our microcontroller, and this is the signal we're gonna get. In the output button, let's put that out, P1 to pulse. We are going to have to manipulate this incoming signal to make a pulse right here. You see that? Bam. Alright, so yeah. We could probably just cheat. Could we cheat? I don't know. Could we create an output? But let's not cheat. We're gonna need to take this signal. Alright, let's start. Alright, what am I gonna do? Move P0, because that's our input signal, to accumulator. Alright, now it's gonna be in the accumulator. So now the first time around we actually want to display the signal, so we're gonna move accumulator to P1, then we're gonna sleep 1. Man, my 1 is weird. I press 1 and I get an 11 every time. Anyway, so now we hear, you can see we're here because we just took the signal for P0, we replicated it and then we slept 1 time unit, and now we're here. But now we need to take the same signal that's in the accumulator and not read it. Yeah, and this is where I have to do some weird if statements. So I have the PDF data file on my phone. You know, guys, I'm recording with Fraps and it'll only record in-game. I'm gonna get smart on the OBX recorder, is that what it is? So I can actually record my entire screen and I can show you guys the data sheet. But I just wanted to get this video out fast, because this game is awesome and I want to get people into it. So I'm going to look at my phone and figure out what I gotta do next. Because that manual is on the phone, that manual from the game, which is just a PDF file. Alright guys, you know what? Since I want to make this video to where the next few missions, I'm going to take you guys along for the ride where we figure this out together. But for that, I need to be able to record the actual PDF. So I need to download, I've been hearing about OBX, I've been meaning to download it and make it work. And then I'll make another video, I'll pump this introduction video out, and then I'm going to tweak some more. I really want to get this out there. This game is amazing. I mean, like, this is real. Like, you guys can now find, and these parts are cheap. Like little, like, simple microprocessors like this are super cheap. I mean, you can literally take this stuff and make it in the real world, and that is just fantastic. Anyway, guys, I'll see you. I'll have a new video up shortly, and we're gonna finish this pulse generator. I'll see you guys in the next video. Thanks for watching. I'm out.